But then the challenge that, especially in a country like India, most good ideas are stillborn. They don't make it out of the creator's brain. And those that do end up costing the creator his soul.
All right then, good afternoon and good to be back in a wonderful studio like this. It's always a pleasure.
Yeah, the last episode was fun.
Yeah, it
right?
was.
So,
one thing. I think it's a fair disclaimer to everyone of your audience there that we are not related.
Wonder why you'd say that. But
I just wonder.
But any case, the last episode we kind of looked at why the engine of Indian thought died out, right? And so the next thing I kind of started thinking about is, what if it had been alive, right? How would it have changed? Because there's a ton of stuff that's happened in various fields. So how would it have changed? How would it have modernized? And in this episode, that's what I wanted to cover.
Sure.
Right. So the very first change actually comes with the incorporation of the scientific method. And in order to do that, the story that we're going to go through is Haytham's Cellar.
Haytham's Cellar. Okay. There you go. All about Haytham.
So Haytham, right, like many of us, was an applied mathematician, right? And when you're good at math, you feel that you can solve any problem. And with that, he went to the Caliph of Cairo and the Fatimid Caliph, and he told him, you have a big problem, and that's the flooding of the Nile. Guess what? I can solve it for you.
Oops.
And this guy was smart enough to believe that he could, and the Fatimid Caliph had enough respect to think that he could. So he shows up in Cairo, spends a couple of years, and figures out that he can't solve the problem. So you don't want to tell the Caliph that.
The Nile isn't listening. The Nile isn't listening to his math equations, is it?
So he needs to hide himself. And he decides to escape the Caliph by pretending to be crazy. So he locks himself up in a dungeon with no light and spends years in there, right? And sends out word to the Caliph that he's gone nuts and he's done this. So one of the interesting things that happens during that time is that there's a tiny little hole through which light comes in. And he sees that the building outside his cellar is reflected on his wall. Upside
so he's
down.
The guy.
Upside down. Mm-hmm. So the camera obscura effect. So he's puzzled and he's interested. So he's by now he's been exposed to people like Ibn Sina, so he understands the structure of the eye and the physics of the eye. So he starts developing a theory of why that would happen, right? And does it from observation, and then he decides that he really wants to truly understand that phenomenon. So he tries varying a bunch of things. He varies how far the object is. He varies the size of the hole. He varies the angle of light, and so on and so forth. Does a bunch of different experiments, and eventually comes up with a full-blown treatise called the Book of Optics. Even today, he's called the father of optics. The interesting thing about it is that it's the very first time that somebody formally and deliberately did the process of hypothesis, experiment, observation, analysis, and feedback. Done very, 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 very rigorously. So he's also called the father of the scientific method. Now, it turns out that in the Middle East, it didn't get much traction. The book did get traction, but it didn't become a standardized process, right? But it made its way to the West in the 14th and 15th centuries. A translation by a Polish friar called Whitehead, right? And everybody, all the scientists in Europe read it.
Right up there on the Amazon's bestseller list.
Bacon, Galileo, Isaac Newton, all of them read his book. And the West owes a ton for its development of the scientific method to this man.
Wow.
Right? So he could legitimately be called the father of modern science. The lessons for us, though, in how we recraft the Darshana is in three different areas. Now, one of the things that Western scholars did, by the time his book made its way to the West, the printing press had also come into being, right? So what they were able to do is actually structure the process of scientific innovation. So experiments that were written down and published, so you could have peer review, the likes of journals and the ability to share results and to be able to replicate experiments, all of that became a standard of scientific thought in the West. So the implications it has for the Darshana, let's start with pramana. So if you look at the four pramanas, I mean, two you can basically get rid of, Shabda and Upamana.
You did mention, it was controversial to start with.
Not only just controversial, it doesn't.
Right,
it's not rigorous enough. It's not rigorous enough.
Right.
Either you perceive, or you kind of infer from your perception. But it doesn't have a proactive element to it. How do you actually verify truth by hypothesizing and then validating it? So that piece of it needs to come into pramana. The second place where it has a major impact is samvada, which is essentially how do you as a community develop knowledge. So the idea of documenting rigorously your experiments or your hypothesis and being able to replicate it and being able to critique it in a larger framework rather than just through debates. That becomes a crucial part of samvada. But the most important change, I believe, is to prama, or your propositions about your model of the world. See, one of the things that the scientific method does is that no propositions are absolute truths. So even if you say that the world is round, you're saying it with a degree of confidence. It may be 99.9999%, but there's still a degree of confidence. So when new pieces of knowledge come into being, the initial hypothesis and the validation allows you to say something with a degree of confidence. And over time, as evidence gathers, that degree of confidence keeps going up. So the benefit here is that within your body of knowledge, you can have conflicting propositions. And over time, evidence will make one more accepted than the other.
Sweep a few away and bring in the fresh.
So that if in order for that process to happen, the pramayas need to have a degree of confidence attached to them. Case in point is you remember Young's double slit experiment. Before that, the conflict was, is light a wave or is it particles? And at the end of the process, it turned out it was both. So if we'd not been able to accommodate two conflicting points of view and give them equal reverence until you had evidence which weighed one way or the other, and you can see many examples of that in scientific life, you wouldn't be able to. So in these three areas, the prama, the pramana, and the samvada, this makes a significant difference. So that's the first change. That's the first change.
I understand where you're getting in terms of the fact that unless you have, a kind of an acceptability of the fact that this may happen,
right,
you're not ready to actually bring in the other conflicting thought in place itself.
That is correct. That is correct. That is correct. So that kind of concludes the impact of the scientific method on our concept of the Darshana. The next piece that we'll be talking about is essentially a dive into analytic philosophy, where precision about the meaning of words starts becoming really important. And we'll talk about that in Wittgenstein's poker.
Wittgenstein's poker.
Fascinating story. So, Cambridge, 1946, and a gentleman by the name Karl Popper. He's a moral philosopher. Is giving a lecture, and on the dais are two other famous philosophers, Bertrand Russell and Ludwig Wittgenstein. And Wittgenstein, by this time, had essentially written that all philosophy was language games, and there were no real questions or answers in philosophy. And challenges Karl Popper to come up with a real philosophical question. And while he's doing that, he has a poker in his hand. End of that discussion, Wittgenstein walked out, and Karl Popper later claimed that it was because he'd answered Wittgenstein that a real philosophical question would be, is it moral to threaten a visiting lecturer with a poker? With a poker. But Wittgenstein and Russell, fascinating characters. And they really illustrate one of the few things that we need to bring into our construct of the darshanas, especially Brahma. Most of the words that we use today in our daily discourse and in actually building language systems are imprecise. So, for example, think about the word sustainable. I'm not dishing the construct,
itself, right.
But the word itself is very imprecise, right? And Wittgenstein had a habit of poking holes through imprecision. So Russell, after writing his famous book, Principia Mathematica, where there was an attempt to unify all branches of mathematics, tried to do the same with philosophy. Unfortunately, that draft fell in the hands of Ludwig Wittgenstein, who gave him a scathing critique, at which point Russell decided not to write the book. But the bottom line of that entire effort, which culminated in Wittgenstein's Tractatological Philosophical, was actually the attempt to represent all language propositions in symbolic logic. So, for example, if I say F is equal to ma, force is equal to mass times acceleration, Newton's second law, it's basically 5 symbols. F equal to m into a. And a specific piece of knowledge is being expressed rigorously by that statement. So we need to apply that kind of rigor to our prama and prameya. Every piece of prameya needs to be expressed as a piece of symbolic logic if you're rigorously building a knowledge system. And the second important thing is that the underlying construct, so if I say force, is something that should be mutually agreed on. So I'll tell you why that's important. So for example, if you and I are outside and we see a tree and we both agree that that's a tree, there's not really a tree there. There's just a bunch of atoms, right? And it's not the same thing that we're seeing because the neurons in your brain are different from the neurons in my brain. So we're actually experiencing it very differently too. All that is common is that we have a symbol, a tree that we are using that you and I can agree to. It's a phenomenal, magical process, but that's all it is.
Sure.
So these two aspects need to be specifically built into how we represent our prameya and prameyas. So at this time, having made these changes, I thought I was at the end of my journey. But that wasn't to be.
Right. So Nandu, with Alhazen and Wittgenstein, so you've kind of brought in the fact that, there needs to be a process, clear, defined scientific process at hand. Also with Wittgenstein, the aspect of precision, right? Being
right.
precise as far as the construct is concerned.
Correct.
I would have thought that would have ended the deal. So what's left?
So I then took this and applied it to a bunch of different areas that I was interested in. For example, economy, governance, and so on, and even my own personal life, right? And I realized that I could come up with lots of wonderful ideas that could be implemented. But then the challenge is that, especially in a country like India, most good ideas are stillborn. They don't make it out of the creator's brain. And those that do end up costing the creator his soul. Right? So it's not enough just to have a really good framework or a methodology in order to think about things. You need really to have an engine that drives the process. And that kind of made me a little disappointed with all my effort. And then out of the corner of my eye, I was sitting and watching this. I saw a statue of Shiva's Tandava. It's there in everybody's house, right? So I saw one. And it kind of sparked in me something that I thought would be a good basis for how to define that engine. So that'll be our next episode.
Oh, wonderful. Look forward then.